This video, we will talk about factoring out a monomial. So our prompt here is factor out the greatest common factor. If the greatest common factor is 1, just retype the polynomial. So in our last video, we talked about finding the GCF of 2 terms. We could also do that of 3 terms or however many terms we wanted. So in this case, we have 2 terms. We have 10u cubed minus 8u squared. So our 2 terms are 10u cubed and a negative 8u squared. So we really could view these. Let's just view these terms as this 10u, right? And we could view the this as negative 8u, right? And even more specifically, to solve to figure out how to factor by a monomial, let's really just look at these terms. We have 10u cubed and we have 8u squared. The minus we're going to take care of in a minute, but let's just look at those factors first here. So if we look at our coefficients of 10 and 8, we have to think of a number that goes into both 8 and 10. That's the highest, right? That's the greatest. So numbers that go into 8 evenly, we have 1, 2, 4, and 8. So 8 doesn't go into 10 evenly, 4 doesn't go into 10 evenly, but 2 does. So our coefficient factor that's common, that's the greatest, is a 2. Now let's look at our u cubed and u squared. We're going to choose the smaller exponent, right? Because u squared, it's u times u. U cubed is u times u times u. So we have to find what's common in both are 2 u's, right? So u squared. So the reason I'm writing it kind of offset here is I'm actually going to rewrite that even a little bit further. Is now you want to place a parenthesis, and what goes right here, we want to get back, we want 2u squared times what gives us 10u cubed, right? So it's almost like you're looking at it like so. 2u squared times what gives us this? So 2 times what gives us 10 would be 5. Oops. And my greatest common factor is u squared. I need u cubed, so I need 1 more u. Right? And we could check this now. So this is piggybacking off your multiplying polynomials, in this case monomials. So 2u squared times 5u is 10u cubed, and that gives us this back. Right? This minus here, we're just going to bring down. So that's what I was mentioning earlier. Just bring that right down. So now here, we need to figure out how many 2's are in 8, right? So right here matches this term. So 2u times what gives us 8u squared, right? So 2 times 4 gives us 8. And u squared times its 1, right, or nothing, gives us u squared. So this is our final answer. We have 2u squared times 5u minus 4. And again, you can always check it by using your knowledge of our last lesson. So if I have 2u squared times 5u minus 4, I can distribute this 2u through. So 2 times 5 is 10u cubed. And 2u squared times 4 is, excuse me, a negative 4 you could view as a negative 8u squared, which is the same as our original. So it's really helpful to check these. Every time, just check it, then you know you're right. So let's look here. Factor out the greatest common factor of 4s cubed minus 20s squared. So I'm going to just line us up here so we have an outline. So if we look here, I want to factor out a number of 4s. Well, let's just look at the number. Factor out a number of 4 and 20. Remember in our last video, always ask yourself if the smaller one goes in the larger. So does 4 go into 20? And it does. 5 times, right? So 4 goes into itself, 4 goes into 4, and 4 goes into 20. Now let's look at our variable term. We have a factor. We have s cubed and s squared. So we want to choose the smallest. S times s here fits in this. So now we want to capture that as our greatest common factor. So the thing that lives on the outside of the parenthesis is your greatest common factor. So 4s squared times what gives us 4s cubed, right? So it's kind of like we're going like this. So 4 times 1 gives us 4. And I have s squared times s gives us s cubed. All right, I'm just going to bring my minus down. So 4 times what gives me 20 would be 5. S squared times 1 gives me s squared, so I don't have to put anything else. So I have 4s squared times the quantity times the difference of 1s minus 5. Something helpful here is, remember from past lessons that 1s is the same as s. So this simplified would be 4s squared times s minus 5. Right, so I changed a sum of terms, in this case a difference of terms. I changed that into a product of factors, right? This times this. These are my two factors here. Or the one above, I have this factor times this. I took it out of a sum of terms and broke it into a product of factors. Next, we have 11s squared minus 11. So I like kind of setting it up right away. I look at my two numbers. 11, I know I can factor out of both of those because it's the same number. I can't factor an s or s squared because there's nothing here, right? So now I need to ask myself, 11 times what gives me this, right? 11 times s squared. 11 times s squared is 11s squared, right? And 11 times what gives me 11 would be itself. It would give me a 1. So my GCF is 11, but this sum of terms changes to this product of factors. Don't get discouraged by how big the polynomial may get. If I want to factor out the GCF, it's the same logic. This one I'm just going to kind of prep us. This term, this one I'm not going to highlight my pluses because I'm just going to bring those down. And I'll go like this also. So let's find our GCF of these terms. So let's just look at the number coefficient of 33, 11, and 11 would be 11. Now let's look at our k. I have k to the 10th, k to the 9th, and k to the 6th. So the smallest of those is k to the 6th. So there's my greatest common factor. Now I want to ask myself, this times what gives me 33k to the 10th? So 11 times 3 gives me 33. And I need 4 more, I need k to the 4th, or 4 more k's being multiplied to give me k to the 10th. Bring down my plus. Now 11 goes into 11 once, so I'm not even going to put it, but you could put a 1 there if you chose to. So k to the 6th times k cubed gives me k to the 9th, because k to the 6th times k cubed here gives me k to the 9th. Next, 11 goes into 11 once. K to the 6 goes into k to the 6 once. So I just have a 1 there. And remember, you can always check this by distributing the greatest common factor back through. This next one, factor out the greatest common factor of this polynomial here. So I have, for my coefficient, I have 13, 26, and 13. So I can factor out a 13. For my variable factor, I have b to the 6th, b to the 4th, and b to the 4th. So I'm going to choose the one that fits in all of them, which is b to the 4th. And my variable, my next variable factor is c to the 10th, c to the 9th, and c to the 8th. I can factor out as c to the 8th, parenthesis. So 13 times 1 gives me 13. B to the 4th times b squared gives me b to the 6th. C to the 8th times c squared gives me c to the 10th. Bring down your plus sign. 13 goes into 26 twice. B to the 4th is already there. C to the 8th times c to the 1st will give me c to the 9th. Next, 13 goes into 13 once. B to the 4th goes into b to the 4th once, so I don't need to carry anything over there. C to the 8th goes into itself once, so that's it for that last term. So just to rewrite this a little bit more properly, I have 13 b to the 4th c to the 5th times b squared c squared. I just dropped the coefficient of 1 there, plus 2c. I just dropped my exponent of 1, plus 1. So I know, like IXL will accept this. There's nothing wrong with including like this one here or this one, but multiple choice on assessments, definitely this is more proper without the coefficients of 1 and without exponents of 1. So now we just went through a couple examples of how to factor out the greatest common factor of a polynomial. So now practice this lesson in IXL. I believe it's called factoring out a monomial from a polynomial. So the way we get more comfortable with it and comfortable with it is practicing, right? Practicing in IXL and you actually doing the work. I do hope you're seeing the connection between our last learning plan and this one. Right before, you were prompt with this, right? You were prompt with distributing this through and multiplying polynomials. Now you're doing the opposite, right? You're getting the answer per se or the product, and you want to change that into factors, right? So I hope you're seeing the connection, and I hope you're seeing how you can always check your answer to make sure you're right.